In this presentation, I'm going to go over some examples and show you how to graph piecewise defined function. In our first example, we have a piecewise function. One piece is for a straight line, a linear function for all the values of x that are less than 0. And the second piece of this function is a constant function, horizontal line, for all the x values greater than or equal to 0. So f of x equal to 4 over 5x plus 1 has a y-intercept at 0, 1, and slope of 4 over 5. So we're going to start this graph by going to point 0, 1. We're going to go 4 units up, and we're going to go 5 units to the right. And we're going to draw this function. But we're only allowed to take values that are less than 0. So we're going to erase all the values that x are 0 or more. So at 0 itself, we have to have an open end. The second piece of this function is f of x equal to 4, which is nothing other than horizontal line y equal to 4. So we're going to go to y equal to 4, and we're going to draw a horizontal line. But this horizontal line is good as long as x is greater than equal to 0. So for any negative values of x, we need to erase. At x equal to 0, this horizontal line will have a solid endpoint. Let's look at another example. This function has got two pieces. The first piece is a linear function again, with a slope of negative 2/3 and a y-intercept of 0, 2. And a slope of negative 2/3. So we're going to start at 0, 2. Since the slope is negative 2 over 3, we're going to go 2 units down and 3 units to the right. And then we're going to connect, and we're going to extend. Now, once again, this graph is good. This piece of the function is good as long as x is less than 0. So we're going to have to erase everything to the right of 0. At 0 itself, we're going to have an open endpoint. The second piece of this function, f of x, is a quadratic or square function. Now this one I'm going to try by making some points and then graph it. I'm going to pick x equal to 0, x equal to 1, x equal to 2, x equal to 3. I'm picking values that are 0 or more because that's the condition for this piece. When x is equal to 0, y is equal to negative 4. When x is 1, y is negative 3. When x is 2, y is 0. When x is 3, y is equal to 5. There was no need to go to the negative side because x has to be greater than or equal to 0. So 0, negative 4, which is included, 1, negative 3, 2, 0, 3, 5, And then we're going to smoothly connect these. So this completes this graph. So this function was made of two parts. One was a linear function and one was a square function shifted down 4 units. Let's look at another example. For the first piece of a function, we're going to pick values that are less than 0 because that's what the condition is. So if x is equal to 0, y becomes equal to 4. If x is equal to 1, negative 1, negative 1 plus 2 is 1 to the second is still 1. Negative 2, negative 2 plus 2 is 0 to the second power is 0. Negative 3 plus 2 is negative 1, but once we square it, we get 1. So I started at x equal to 0, y will be equal to 4. When x is equal to negative 1, y is equal to 1. When x is equal to negative 2, y is equal to 0. When x is negative 3, y equal to 0. So the more points you have, the better graph we're going to get. So this is the graph of the first piece, but the endpoint should not be included. So I'll make sure that this endpoint becomes open. Now the second piece of this graph, this function, is f of x equal to square root of x. This one I have to be a little bit careful. I pick values that are perfect square, such as 0, 1, 4, 9. Once you plug it in, you're going to get 0, 1, 2, and 3. The endpoint in this one, 0, is included. Then 1, then 4 and 2, then 9 and 3. And then we smoothly connect these points together. So this concludes the graph of this piecewise function. Okay, in this example, we have a linear function, negative 3 over 2x, but the condition is that x must be less than 2. So let's just try points again. So we're going to pick value x equal to 2. Maybe I pick value x equal to 0. And I'm going to pick also x equal to negative 2. For a linear function, you can pick, just few, input values. So when x is 2, y is equal to negative 3. When x is 0, y is equal to 0. And when x is negative 2, these two, they cancel. We're going to get positive 3. So once again, at x equal to 2, I should have an opening because 2 is not included. So x equal to 0, x equal to 2, y is equal to negative 3. This will be open. X equal to 0, y is equal to 0. X equal to negative 2, y is equal to 3. This is a linear function, so we're going to connect them together. But we're not going to extend it beyond the endpoint, only in one side. Now the second piece of this function, I'm going to pick values that are 2 or more. When I square 2, I get 4 with the negative in front of it. We get negative 4 plus 6 will be 2. So when x is 2, y is 2, I'm going to pick x equal to 3. 3 to the second is 9. That makes it negative 9. Negative 9 plus 6 will be negative 3. So when x is 3, y would be negative 3. And this graph is going to go like this. Of course, you can have more values for x, but just make sure that you pick values that are greater than or equal to 2. In this example, our function has 3 pieces. The first piece is absolute value of x minus 4. So for that, I'm going to pick values that are negative 4 or less. So I'm going to go negative 4, negative 5, negative 6. We plug it in, that becomes 4 minus 4y becomes 0. Negative 5 in absolute value becomes 5. 5 minus 4 becomes 1. Absolute value of negative 6 is 6. 6 minus 4 is 2. And this endpoint is included. The second piece is a straight line, y equal to negative 6. But we're only going to pick values between negative 4 and 4. Or you can draw a horizontal line, but erase everything that is outside of 4 and negative 4. Now, neither 4 or negative 4 are included, so the endpoints will be open. Now, for the second piece of this function, we're going to pick smart values starting with 4, because that's where the condition is. 4 minus 4 is 0. Square root of 0 is 0, so we're going to be at 4, 0, which is right here. Then we're going to pick 5. 5 minus 4, 1. Square root of 1 is 1. Then we're going to pick 8. The reason for that is 8 minus 4 is 4, but radical 4 is 2. So again, the more points you have, the smoother the graph will be, but this graph is going to look like this. I hope this presentation helped you guys understand how to graph piecewise defined functions.